Hello students, we are solving the IB Math AHL past papers and from today we are starting to solve the IB Math AHL November 2021 paper 2. Today we'll be solving the very first question, the question number 1 of this paper, and you will be getting the links to all the previously solved questions of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 1. And since it is paper 2, we are allowed to use the calculator. I'll be using the TI Inspire calculator. So the question number 1 contains a maximum mark of 7 and it says, in Luce's Music Academy, 8 students took their piano diploma examination and achieved scores out of 150. For her records, Lucy decided to record the average number of hours per week each student reported practicing in the weeks prior to their examination. These results are summarized in the table below. Average weekly practice time H and diploma score T. Okay. So number of hours, average time, weekly practice time in hours. Okay. So we are having, actually there are 8 students. So we are having 8 pairs of data and we have to first of all input them in our calculator in a spreadsheet. So let us go to that. Okay. And this is okay, where is it? Yeah. And this one is the diploma score. So let this be D. Okay. D. Fine. And now we have to enter the values. 28, 13, 45, 28, 13, 45, 33, 17, 29, 33, 17, and enter 29. Okay. And we move to the first row of this column. And this is, did I write 39 and that 36? I'm not sure. Let me see. Sorry, 39 and 36. Did not enter two more. 39 and 36. Fine. Hundred and 82, and 120. 115, 82, and 120. 116, 79, and 101. 116, 79, 101. 116, 79, and 101. Okay. 110, 121. 110, 121. Complete. Okay, fine. Now we have to get the, now coming to subpart A. Find Pearson's product moment correlation coefficient R for these data and it contains 2 marks. Obviously, it cannot contain more than 2 marks because we have to just copy the answer. We don't have to do anything, any calculation. So we go to menu and we take statistics and stat calculations, and it should be the linear regression mx plus b. You have to take the mx plus b, don't take a plus bx. Okay, so mx plus b, and the x list is h and the y list is d. Okay, and we don't have to do anything more, and it is this. Fine. So this is the linear regression title, and this is the equation mx plus b, m value, b value, then we need the r value. R value is this one, 0.88352. So we have to give the answer to three significant figures. So it will be 0.884. Okay. So R value is 0.884 up to three significant figures. Okay. Fine. Coming to subpart B. The relationship between the variables can be modeled by the regression equation D equal to A times H plus B. Write down the value of A and the value of B. Let me write the answers for the subpart B over here. A will be equal to, see, they have given the equation D equal to A times H plus B, and our equation is Y equals M times X plus B. Therefore, A is equal to M. See, the A value is 1.366. This is up to four significant figures, so I'll be taking 1.37. Okay. Let me take 1.366 and then I'll be getting only the final answer in up to three significant figures. 1.366. So it is 1.366, which is 1.37 up to three significant figures. Okay. And B, what is the B value? This is AH plus B, and over there also it was MX plus B. So the B is the same. The variable name is the same. 64.517. 64.517. Which is almost equal to 64.5 up to three significant figures. Okay. So we have answered, this is B. We have answered subpart B. Coming to subpart C. One of these 8 students was disappointed with her result and wished she had practiced more. Based on the given data, determine how her score could have been expected to alter had she practiced an extra 5 hours per week. 5 hours per week. Okay, so coming to subpart C, we have the equation as it is D is the dependent variable, H is the independent variable. So it is D of H can be written as 1.366 I'm taking, okay, times h plus 64. Since I have taken four significant figures for A, I am taking four significant figures for B as well. 64.52. Okay. So now this is the equation. Now they are saying that for any value of h can be 28, h can be 13, any value. The d value can be found if the h value is known from this equation. Now they are saying that this particular student wished to know the score, that how her score could have been expected to alter had she practiced an extra 5 hours per week. So, whatever was her current value of h, that would get transferred to or changed to h plus 5 because she expected to or she wished she could have practiced 5 hours per week extra. So, h will be getting changed to h plus 5. So, this is therefore d of h plus 5 is equal to 1.366 times h plus 5 plus 64.52. Okay. And if we just expand this side, this is equal to 1.366h plus 1.366 times 5 plus 64.52. Okay. So this is equal to 1.366h is there. And what is this? 1.366 times 5. We are having the calculator, so we go to the calculator. 1.366 times 5. 6.83. Okay. So it is 6.83 plus 64.52. So this is the score that she would have expected to get had she practiced 5 hours extra per week. And this is the score that she has attained. So, what is the extra score for that? We have to just subtract these two values. So, this is, I'm coming to this point. So, therefore, her extra score would have been equal to 1.366h plus 6.83 plus 64.52 minus the same thing, 1.366h plus 64.52. Okay. So this and this will be getting cancelled, this and this will be getting cancelled. So this is equal to 6.83. Had she practiced 5 hours per week extra, she could have expected to get an additional score of 6.83. The score she could have expected to get would have been what score she has got at present plus 6.83. Okay. So this completes our subpart C. Let us move on to the next subpart. Subpart D. Lucy asserts that the number of hours a student practices has a direct effect on their final diploma result. Comment on the validity of Lucy's assertion, and this contains only a single mark. Um, what we can see is, before that, let us just check what was the R value, what was the coefficient of correlation coefficient. It was 0.8835, so 0.884 up to three significant figures, which is quite good, quite a strong positive correlation. Okay, so um, let us write, since R is equal to 0.884, let me see once more, let me just check. 0.884, right? We find a strong correlation, strong positive correlation rather, between I'm writing H and D, the number of hours practiced per week and the diploma score. Okay. But uh, correlation does not prove positive correlation means that we are seeing that as the students practiced more number of hours, their scores were better. Okay, than the students who practiced fewer number of hours per week. But the correlation does not prove a causal relationship. Therefore, Lucy may or may not be correct. May be correct because this is what we usually think, that you practice more, you study more, and you will be performing better in your examination. So that is our belief. Okay. So that is how Lucy is also believing. But it may or may not be true because maybe there were some other factors which affected the studies. Maybe the students who, maybe not all of them, if not all of them, but there may be one or two students who were quite good in piano, but they had some other distractions, or they were not, they were ill, or there were something going on in their family, or whatever it is. There were some other factors which affected their performance negatively. Okay. So it is not that the number of hours practiced is only one factor which will be determining the performance. It is definitely one of the major factors, but definitely not the only factor. Okay. So therefore, Lucy may or may not be correct. Fine. Now coming to subpart E. So that Lucy suspected that each student had not been practicing as much as they reported. In order to compensate for this, Lucy deducted a fixed number of hours per week from each of the students' recorded number of hours. And Sapat E states how, if at all, the value of R would be affected. And this also contains a single mark. How do we get the value of R? If we draw this part was for Sapat D and this is for Sapat E. Suppose the H was the independent variable and the D was the dependent variable. So this is H and this is the D. And and you will be having the scatter diagram, maybe like this. Okay. I have drawn many more points. There are only 8 students, but anyway, I'm just showing what is happening. If the and we draw the line of best fit, maybe it may pass through zero, it may not pass through zero, whatever it is maybe this is the line of best fit. Okay, and there may be 1 or 2 points which will be on the line, and there will be definitely other points which will not be on the line. But how will the R value get affected? As you have the other points which are not on the line, the more they they are near to the line, the more is the strong correlation. I have drawn a positive correlation. So as you have if the number of points that are not lying on the line are very close to the line, they are not on the line but they are really close to the line. If they are close to the line, you will be having strong positive correlation. If you are having very close to the line, the other points which are not on the line, you will be having a very strong positive correlation. So the distance between those points and the line of best fit determines the I value, R value. Okay? And if C is just subtracting a fixed number of hours from each of the students' reported number of hours, then what is happening? There will be a horizontal translation towards the left. If a student has reported to have practiced for say 15 hours per week, and if Lucy deducts 5 hours, so maybe I'm not having the equation for 15 hours. I can go back and check what will be the corresponding score for 15 hours if a student practices for uh, 15 hours per week. But he or she will be getting a definite score. But if Lucy suspects that the student has actually practiced for 10 hours per week, then suppose the point is 15 comma D right at this moment, or capital D. And if the 5 hours is detected, then the point will be 10 comma D. Then what will happen? There will be a horizontal translation towards the left. The D value remains the same. So the height above the line will be the same. But it will be coming, because I'm not talking about a single point. All the points that are there, it's getting shifted towards the left by whatever, maybe the number 5, 10, whatever it is. So the points are just getting translated left side. But the line will be having the same gradient. Okay, they are just getting shifted horizontally, so that again the in any case the line will be having the same gradient. It will be parallel to this original line. Okay? So the difference between the line and the final position of these translated points will still remain the same. Therefore, just deducting the number of hours will not be affecting the value of R at all. Okay. But you don't have to write so many things because it's just containing a single mark. So don't waste your time. Just you write that the value of R will remain unchanged. Okay. So this brings us to the end of this question. We have solved the very first question of this paper. And I'm Nilanjana Sanyal. I'm an online IB Math ASL and IB Math A HL tutor. I tutor students from within India and outside India. And thank you for staying with me till the end. If in case you are liking my explanations for these past paper questions, please give me a like, which will be motivating me. And please do share these videos with your friends so that even they can get benefited by going through these videos, by listening to these explanations. And please subscribe to my YouTube channel, because in that case you'll be getting notified as soon as I publish a new video. Okay. And we meet again in our very next session, where we'll be solving question number 2 of the same paper. So till then, bye.